So sorry for disturbance in previous session. So let's see some of the important question on prefix sum. So we know the basic concept and we understand how to use prefix sum. So the question comes from the prefix sum are as follows. So important, important question are as follows. Okay, what is the question? Important question are as follows. So mm, we see the question on range query. Okay, range query. Okay. After that, left and right some differences. Left and right, right some differences. Okay. Count the vowel range. So in a range problem comes with prefix sum range. Minimum penalty in penalty in shop. Okay. After that, find good day to rob a bank. Sum of absolute difference in sorted array. Okay. उसके बाद product of the last k number and product of last k number, product of last k number. Okay, number. I find all good indices or robot movement, robot movement, robot movement. Okay, and minimum cost to make a array equal and mean cost to make array equal. Okay, these are the common problem on the prefix sum. Let's see one by one. So let's see. Mm, so so let's see range query. Range query problem we already solved in this section. Okay, range query problem already solved by us. Okay. Mm, so range query already we solved. Left some differences. So in the left some differences, what we have to do? Left and right some differences question. So in this problem, what we have to do? Mm, left and right some. So in this question, you are given a num, so compute I to left side sum and right sum is equal to equal. As we see earlier, simply we don't have to do. We take the n is equal to nums dot size and we have to nums dot size. Okay, and we have to maintain a right sum and left sum. So there is two vector int For the left will be n, and the vector int right will be rigst, right will be n. Okay, so after that we start filling the filling the left vector with the starting from 1 to n minus n, and for the right vector we have to start from the previous one. Okay, well, from the n minus 2. So for int, from the int starting from the I is equal starting from the 0 and go till n. Okay, so in this case what we have to do, simply left of I is equal to left of we fill the value left of I minus 1, so start with 1. Okay, left of I minus 1 plus AR of I. Okay, similarly uh, similarly similarly for the right one, I start from the n minus 2. Okay, n minus 2 and goes till 0. Okay, goes till 0. So what we have to do in this case, we have to right of I is equal to right of I plus 1 I. Okay, this one. So absolutely we have to store the left and right differences. So in this case again run the loop. Okay, starting from the I starting from the 0 goes till end, and the answer of I stored the value of absolute difference of left of I minus right of I. Okay, and return the answer. Okay, it's a simple one. So left and right vector is simple. So in third question, we have to count the vowel in a string range. So we simply given you are given an array of lowercase of word and the list of the queries from left eye to right eye. From till we have to count the vowel range. So queries are just example, we are given a string of words, a vector of word containing the string. So in which whatever word vector in which everything is given like ABC, okay, ABC comma DCB, like this everything is given. Okay, and we also have given a queries in which we have given 0 comma 2, okay, 0 comma 2, 1 comma 4, okay, like this. So we have to find the range of no, we have to count the number of vowel exist in these range. So A and E, only E is valid. So how many string in the one word li and a start and end with vowel? So we have to return how many of the string will start with vowel and end with vowel. So we have to. So let's see how we write the code. Let's see how we write the code. So text containing this one. Here is so first of all we have to check. We have to check the value. So how we check the value is vowel or not? So in this case we have to maintain a boolean function is vowel, in which we have to send a character send a character. We have to check return a string that is A E I O U. Okay, A-I-O-U dot find and what and a string dot and pause, string equal to and pause. Okay, so through which we can check it is vowel or not. So vowel or not. So after that, in the main function, containing the of int of vowel count, vowel string, what we see, in which a vector is given. So vector of string, what is given, okay, what is given, and the vector queries is also given. 2D vector of queries is given. So 2D vector of queries is given. So left like this. Okay, main logic is that what we have to do, simply we have word dot length, word dot size, okay, word dot size, and prefix value. If we see previously, store that value. Okay, so vector of int of pre, in which the size is n plus 1 and all initialized with the 0 value. Okay, after that we start the for loop from the int I starting from 0, I less than n, I plus plus. Okay, what we have to do, we have to check the each character in the word. So string and then w each character word. So this one is string word of I. Okay, after that we have to check on to store the value p of I plus 1. P plus I plus 1 is equal to plus we have to front and back. If if it returned 1, so we have to add this one. So is, we have to check is vowel what, w dot front is vowel w dot front, and is vowel w dot back, or back. Okay, from this we have to check and store the value of this, and the everything is stored in our fix vector. Now we evaluate the query. So we store the value in the range answer, and for auto, run the auto function for the all the queries we needed. So all the queries. Okay, for auto, answer dot back, because all the answers stored in the this one. So we have to return how many element exist or not. So in this case, what we have to do, simply pre of what, pre of q of starting element, plus 1, minus p of uh, final minus initial. In this case, through this we can store the exact answer, how many string having starting with the vowel and ending the vowel count, and then return the answer vector. So return answer vector. So answer vector. So this one is the easiest and straightforward question on the prefix sum. Simply we have to use this one, return string of this dot find character, if not string dot end, string and pause. Okay, so let's move forward for the next question. Minimum penalty for the SOP. In this case, what we have to do in this, okay, everything is correct. So let's move forward. For the next question. So minimum penalty for a SOP. Okay, so in this question, what we do, a given a SOP is open for 0 to n minus 1 hour. The customer come in a string customer, where y is when a customer come that hour and n for the customer and min no customer. If a shop close at the hour h, so for every y before h minus 1 is penalty. Okay, for every y before h minus 1 is penalty, for every n before h minus 1 is penalty. So what we have written? So close at 2 hours. So let's this one is a pretty straightforward question. So let's check for the another question. The next, find a good day to rob a bank. So given an integer security of number of guard on that day, an integer time, if a day is a day I is good if for the previous time security of j is greater than for a day is good if the previous day's security I is greater than security of j plus 1 in non-increasing order. For the next time security of j for the next day security of j is less than, well, in this we have to see the like we have to see uh, the security in previous day is high, on next day is higher, but today is a less one. So in that day we have to do the uh, okay, j therefore, so this one having greater good day if previous day value is greater than today's day or unequal, and today's day increase and decreasing order. So we have to maintain. In that case, this one is question for the good day to rob a bank. Okay, good day to rob a bank. So int n is equal to security of that size. Okay, so here two vector int left one zero value, and then security of n of 0. Okay, after that also create a vector of answer result. Okay, what we do, simply check the all the left element is decreasing or not. So int I starting from the 1 and goes till n. Okay, and check left of if what to check if security of I is less than is equal to security of I minus 1. So previous date security is more than today's date. In this case we have to increase the value. Okay, what we have to do, simply increase the value left of I minus 1, left of I is equal to left of I minus 1 plus 1. Okay, so increment the value. For the next one, for filling the from the right side we have to check the if, from this side we have to say decreasing order, and from this side we have to check increasing order. So for loop we start from the previously I is equal to n minus 2 to till 0. We have to check if the security of I is greater is equal to less than is equal to security of I plus 1. today's security is less than negative security. So we have to put this one. So in this we simply increment the value, right, plus 1 value plus 1. So everything is okay. Fill the value. What we have to return? We have to return the index. Good time for the good time for the, so I is equal to, the time is given, and the time is given, and time is 2. So and the time is given. Oh, so time is given. So start from the time till n minus n time. We have to check left of I is greater than time and the right of I is greater than time. So in this case we have to push the value. So I is given a time value, and we have to run this loop till n minus m time. Okay. In this case, if left of I greater than is equal to time, left of I is greater than is equal to time in this case, and right of I is greater than is equal to time. In this case the condition is true. In this case we have to put the result value inside the vector. So push underscore back what I. Okay. So this, and finally we have to return the result. So this one is basic. We have to storing the two vector, initializing the two vector left and right, and fill using the concept of prefix sum, and check the condition by this one. So this one is a straightforward question for the prefix sum. Also similarly, like question product of array except self. So given an array, return an array answer such that array of I is equal answer of I is equal to product of some array except than 1. So array, question known as product of array except self. Okay, except self. So in this question what we have to do, we already know that given an nums array, and in this we have given 1 2 and 3 and comma 4. So what we have to do, and we have to return, so except 1, product of the array except 1. So till this 24 is answer. So create answer vector in which we have to store the value 24. After that we leave this value and product all the remaining values. So 3 into 4 is equal to 12. Okay. Similarly for this one, 2 and 8, so 8, and after this one is 6. We have to return this one. So how we do this one? So how we do, and we have to do inside the, so we store the value of prefix side sum and suffix side sum, and in answer we have to return the all value. So prefix side sum is equal to 1 2 6 and 24. Okay, 1 2 1 2 6 and 24. On the left side it become 4 12 4 12 24. So product of I, product of before I, 1 2 3 and 24. Product of I after I, 4 12 24 and 24. Okay. Previous one most of I understand. So 1 1 into 2 into, we simply do the value. So let's add the code. So we don't need to worry. We have to maintain the two vector prefix of I, which store the value, which store the product 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 of nums before I, okay, before I, and the suffix of I is equal to store the product of nums after I, okay, after I. So and after that the final answer will be sum of prefix of I into uh, into into suffix of I, okay. So let's write the code. Mm, so let's write the code. So and int n is equal to nums dot size, okay. After that we have to check vector of int p, in which all the value from the n, all the value initialized with the one value, okay, because during product there must be an element and suffix n of 1, okay. After that we have to calculate the prefix product. So int I starting from the value 1 and goes till n, okay. So what we have to do, I have to store the value and p of I is equal to p of I minus 1 into nums of I minus 1 value, okay, except that value, okay, except that value. And for similarly for the suffix int and the I starting from the n minus 2 and goes till I greater than is equal to 0, okay. And what we have to do, we also have to product the value. So how we do, suffix of suffix of I is equal to suffix of I plus 1 except the previous value, so nums of I plus 1, okay. After doing this we have to the for loop starting from the I to 0 to n, and the answer of I is equal to product of prefix of I into the suffix of I, okay. Finally return the answer, okay. So let's dry run the dry run. In this we have the let's dry run for this case. For the pre we have to store 1. In this case all the values 1. Pre of I is equal to we start from this value now. So in this case pre of I minus 1. So first value will be 1. After that we move forward. So pre of 2 is equal, this one is become 1 2 to become previous element 1 into so this one value become 2. After that we reach to third value, we reach third value 2 3 and this one. So previous value 2, 3 and 6, so final answer will be 6 1 1 2 2 and 6. Similarly for the suffix value, what we have to write, starting from previously one. So answer 1, okay, 1 1, okay. After that we have to some value 1 into 4, okay. After that we reach minus 1 2 No, we don't. Now we are starting from this one. So we simply store value 1, and after that we store value 4. After that we will store the value 12, 12, 4, 12, 24, n minus 2, n minus 1, n minus 2. So n minus 2 value. So n minus 2 value, and it will be I plus 1, 4 into nums of I minus 1. The previous value is 1 and nums of I minus 1 value, I plus 1 value is 4. So simply we write 4. So after that we reach to this position n minus 3. So suffix of this one is 4, suffix of I plus 1, suffix of I plus 1 value. Through this, okay.